Okay, I'll start. Uh, I'll introduce you, sir, first,
Please.
and then yeah, we can start with the presentation. So, just for uh, yeah, everyone's information. So we'll have the session till 5, and then we'll open the session for question and answers for the next 30 minutes. So, good evening, everyone. And today we have Mr. Sheshagiri Rao with us, who's joined us from his native village, as he says, Pavagada. It's another village near Pavagada. And he's a farmer at heart and manages a large family farm that also functions as a research station in collaboration with IISC. With decades of work alongside leading ecologists, rainfall scientists, and global institutions, and as the co founder of Krishi Hrudaya, an agri-tech startup bringing real time water intelligence to thousands of farmers, his work sits at the powerful intersection of science, soil, and sustainability. Uh, Today, Krishi Hrudaya systems are used by over 1,200 farmers, integrating aquifer monitoring and groundwater recharge insights. They're currently implementing their solution across 4,200 bore wells with BWSS V2. In today's session, we learn about how groundwater, aquifers, and rainfall systems actually behave on the ground, why they remain black boxes, and how practical field ready solutions can help farmers and cities make smarter water decisions. So, welcome, Mr. Rao, and over to you now for the presentation.
Thank you, Diksha, and opportunity. Um, I would be talking about what I have been doing for the past 4 decades. There are two things about water that has intrigued me. One is the rainfall, and other is the groundwater. I am very intrigued by them simply because my well-being depends on these two aspects of water. So I have done a number of things in with respect to this. Okay. So I do have done research for about 3 decades with both the Gadgils and Professor Narasimha. Then I have also worked outside India with Earth Institute, EPF Lausanne, Switzerland, particularly on simulation modeling with crop grow and APSIM in US and Australia. So this has been my research which is related to water. But equally important is my experience in relating to these two aspects, groundwater and rainfall. First experience is as a farmer and an entrepreneur. I manage a large farm. Then I also work with natural remedies, looking at their supply chain for 11 years. So I do understand what happens all over India and many other parts of the world because I have looked at supply chain, which is closely linked to rainfall. Then I have begun a startup where we work on these areas, providing the technology. So that is the experience part. I also have worked with a number of actual on-ground implementers, BIFE, ICRA, Del Monte, Prithvi Energy, Tata Coffee. See, this is where I have gained on-ground experience on rainfall and groundwater both. So what I talk to you today is a combination of research as well as experience. Uh, so let me begin with rainfall. Uh, this is rainfall of where I'm sitting, the region Pavagada, and this rainfall, it has an average of 56.1 centimeters. And what you see here is the anomaly. What goes up is the positive anomaly. What comes down is the negative anomaly. Now you can see the average is meaningless here. There are huge anomalies which are positive and negative. If you take about 120 years, This is how it looks between years. And now I'm just showing the variability of the rainfall. Why is it difficult to work with rainfall and understand rainfall? Uh, in India, we are fortunate to have 130 years of continuous rainfall data for most of India. And now I have just taken the example of our block, our taluk, our 1,000 square kilometer. Now you have similar data all over India. There is no place in India without this data, probably except Himalayas and some tribal regions. Everywhere else you have this data. So what I have done for my region, we have also done for all other regions of India. So though I am speaking about something specific, the same kind of analysis can be done anywhere for any region. Now, this is the average, and here is the distribution. So most of the time you can see we get between 30 to 50 centimeters of rainfall. Most of the time, the distribution is what we see. Now, this is over years. Within the year is what is most interesting for people as well as planners. So let us come to within the year. Now, within the year, in the x-axis, you will see nakshatras. These 27 nakshatras, we have put all the rainfall data into nakshatras. Please don't confuse it as some Panchangam related nakshatra. This is nothing to do with the traditional nakshatras. See, what we did was not just India, entire South Asia, the knowledge of rainfall exists in the time units of nakshatras. These nakshatras are 13-day time units, and this is common. I have explored complete South Asia and some parts of Southeast Asia. All of them use these nakshatras for knowledge about rainfall. So we don't want to tell them July 13th. They don't understand. But if you tell them Punarvasu, they know what it means. So in order to have the common language with the people with a huge amount of experience and tradition, we converted all the scientific data into nakshatras. So this has nothing to do with Panchangam. Please don't get misled by the names. So these are time units which are used to establish, enable dialogue, enable people. So we have converted the entire data into nakshatras. So, and we have also published using nakshatras. I don't see anything wrong in using it as long as the days don't change from year. Instead of a pentad, I use a 13-day time interval. Okay. So now you can see, look at this data. You already know that in the month of July, August, September, this is the peak. This is the peak that is coming. And after October, November, the rainfall reduces. January, February also, the rainfall is there. The pink line is the maximum line. The green line is the average. Okay. The green line is the average. So this is the average and the maximum that you can get. You can already see the gap between the maximum and the average. Now, what is of interest to farmers and is that what is the chance of getting a fixed amount of rain? 2 centimeters rains means you can plow the land. More than 14 centimeters means your tanks will get water by runoff. There is enough runoff. Between 0 to 8, your streams will start flowing. See, these you get benefited by rainfall. So 0 to 8 is stream flow. Above 14, tanks are getting storage water. Now, you can also see there is 0. Now, this big line is 0 rain. Okay. Now, look at these significant events of the impact of rainfall, and they can also be mapped. The variability of these events occurring across nakshatras can also be mapped. And that is what we have done. Okay. And we can go over deeper if required, but I just wanted you to look at how different aspects of rain can be mapped using scientific data. And as I said earlier, this is available for all parts of India, not just my region. This is just a example for you to show. Now, similarly, we talked of rain. Now, what is also important is no rain, what we call as dry spell, right? So now we have looked at 5 to 8 days and more than 9 days. Now, again, these dry spells also show a variation in nakshatra wise. Obviously, towards November, December, the dry spells increase, the dry spells decrease during. So this is how the dry spell probabilities occur. On the y-axis is the probability of occurrence. Okay. So we have probability of occurrence on the y-axis, on the x-axis time units, which is just nakshatras. And this is how the distribution looks like. Probability of the events happening over different nakshatras. Again, let us move on to the reverse of dry spells, the wet spells. When the rain is continuous, it does not stop raining. These are important things for us. Both in the urban and rural, continuous rain without stopping, everyday rain, not continuous rain, everyday rain has a significance, both rural and urban. So this is different sizes of wet spell, 3-4 days continuous rain, continuous raining every day, 5 to 6 days, 7 to 8 days. Now, these are probabilities of such events happening across nakshatras. Now, these are self-explanatory, and this was just to show all these aspects are depicted. We have analyzed these aspects. Now, similarly, you can also look at wet spells over months. I'm going to skip all this. These are just different time units. On the x-axis, y-axis, you have. Now, these are different aspects of data that we have understood. Now, what do you do with this data? What do you do with this knowledge, ability to analyze daily rainfall information? What do you do with this? Now, I take two contexts because they are very different. What do you do with the natural context, and what do you do with the urban context? Natural means I take agriculture and farming. What do you do with the agriculture, farming context, and what do you do with the urban city context? So now, for example, let me talk about first with the urban context. This kind of rainfall data will be very useful. The probability of occurrence, all of that would be very useful to look at flooding and drainage. It is also important to look at recharge of the groundwater. Now, recharge will happen two ways. One is heritage recharge by ponds and things like that. But please realize there are also new opportunities of recharge, like treated sewage. Now, treated sewage is a new opportunity of recharge. So we should look at what should happen with that. Then there are also new technologies that are coming up. Our own company, Krishi Hridaya, we are trying to do direct recharge to the bore wells, directly into the bore well. Smart filter, which can filter the rainwater, maybe 1 million to 10 million per season, and we send it directly into the bore well. Now, how do we do such opportunities? So that is another new technology that is emerging. Then we are also exploring, if we have data, I will come to that a little part. How do we have data? What are the best options for recharge? If you are interested in one particular bore well, or if you are interested in one particular region, depending on the geomorphology and the evidence that you gather, can you shortlist best bet options of recharge? See, these are the questions that are relevant to the urban area. Now, all of them are new questions. I do not have answers yet. But what I want to show to Biome and the network that is working with Biome and the interested people on water is that we have done work on the other environment, that is farming, where we have utilized the knowledge of rain to benefit users. Something similar is possible to do in urban segment as well. What we have done on the farming segment, it is possible to follow a similar methodology. It is not copy paste, and work on urban issues as well. Now, I'll take you through briefly what we have done on the farming side, with the caveat that similar things I believe are possible. This is where we would like to partner with Biome and other interested organizations and work on what is possible. So now, obviously, I don't need to explain this diagram here. There are major differences between urban and the natural environment. First of all, the urban environment has 75 to 100% impervious cover. So the percolation is very, very less compared to the rural one, compared to the farming one, where the percolation is very high because there is zero ground cover, at least in the farming ecosystem, and thereby percolation is very high. Here, about 55% is runoff. Here, about 10% is runoff. These are estimates. They will vary. So there are major differences between urban and rural. Even though such differences exist, what is it that we can learn from our work in the farming ecosystem? The first thing is we identify, I will use the word ecosystem than a segment. In the farming ecosystem, first see that the rain is a trigger for both good events and bad events. By working with users, we actually made a list of such triggers. Now, this is work in detail done to say what is good for you, what is bad for you, and what amount of rain will trigger this bad event. You can see we have gone into great detail and great specificity to define the rain event that triggers this good or bad event. So that is the first thing to do, identify good and bad and what triggers it. And this is the work done indeed. All of these are published data. They will be available for anyone who is interested. And then if you understand these good and bad events, what can you do? If you are able to utilize good events and avoid bad events, you will get a huge benefit. Now, here we were talking of farmers. Here, this was groundnut farmers. Now, please look at this arrow. So, can you look at this black area? This black area means very high yield. This shaded area without shading, without any marks, that means very low yield. So farmers, what were they doing? They were doing the sowing in Aridra rain. That is between around 11. Aridra rain is towards, I should move, the marking is a little wrong, towards 25th June. So Aridra rain is 25th June. They were sowing it there. So they had a very high chance of low yield. Low yield probability is very high. High yield probability is very low. These are the probability graphs. Now, all we did was, by this understanding the rainfall and the triggers, good and bad event triggers, we just shifted the sowing date from Aridra to Pushya rain. So from June 25th, we shifted to July 20th. That is all we did. And now just the shift so late, don't sow early. Even if the rain comes, wait, don't do anything. And that increased the chance of high yield by 3 times. Okay. So this is what is possible if you understand the rainfall variability and the link to good and bad events without any additional cost. They were able to increase high yield probability by 3-fold. And that becomes possible in farming by understanding rainfall variability. Now, I want to not go deep, but show you this. Now, it is not just one crop. See, when something as highly variable and complex as rainfall comes, you need a portfolio of options. You just don't need one crop like groundnut. Shifting groundnut from June 25th to July 20th is a great option, but that is necessary but insufficient. What you need is a portfolio, a basket full of options to look at to work with rainfall variability, and that is what we have shown. On the top of this graph, you will see the top of current cropping pattern. This is what we are doing now. The shaded area, the hillock that you see, is the rainfall climatology. It is rainfall variability over 120 years. We are using a small part of the rain. We get into problems. What we really need is a combination of crops, 25, 30 crops, which can utilize the entire spectrum of rainfall variability. And that was already present in the traditional cropping pattern. We just need to learn from that and utilize the entire rainfall variability spectrum. So this again is published. I would be happy to give you the research paper on this, but this is the strategy. When you want to work with something highly variable, your response also cannot be a single option. It has to be a multi-stage, multi-species option. So this is what we have to tailor our responses to the inherent rainfall variability. So this is the message out of this research that we had done. Now I'll move further. Now, what happens if you do tailoring of your farming strategy, your cropping strategy to the rainfall? Now, here is something that the work that done with Dr. J.N.S. Reddy of BIFE. Now, please look at this rainfall land. This was done near Tiptor. Rainfall is about 60 centimeters. This is no irrigation, completely dry land. The family, it was like this. In the beginning, we started our intervention. It became like this. Then 3 years ago, it was like this. Now it is like this. We could transform this without any irrigation, just using rainfall by this understanding of rainfall variability. And this transformation becomes possible. This is not 1 or 2 acres. This was done in 3,000 acres. So these kind of transformations are possible by intelligently understanding and leveraging rainfall variability to farming. And this is what we want to work towards. As I said, these are examples of how we can leverage the understanding of rainfall variability in farming. What I propose is we must do something similar for urban areas. I am sure urban areas' requirements are very different, but it is possible to understand and work with the users, work with the stakeholders, and achieve spectacular results like we were able to do in farming. And that is the intent that Krishi Hridaya wants to work on. It is just to show a system integrated view that water, our interest is to increase profits. It also needs many other things, not just, and it is an iterative learning. See, whenever we work with complex systems, the learning is always iterative. You need to try out something, see the results, then iteratively learn. And that is what we have done. It has been largely successful. We would like to follow similar system of iterative learning in the urban ecosystem as well, as we have done in the farming ecosystem. And with this, I would close my focus on the rain and its variability. How do we unravel rain and what benefit can we get out of it? Now I want to come to groundwater. And the work on groundwater has been, my interest has been very deep, but some success we have achieved here, but that is all very recent. So I would like to now shift to groundwater. I just want to begin by saying India is in a peculiar position. See, we are amongst one of the most water-stressed regions in the world. But along with water stress, there is also high usage. We are also one of the highest users of groundwater. In fact, we not users of groundwater in the world. So there is already a stress and there is high usage. So this compounds the issue of groundwater, particularly for regions like India. Like India, there are other regions as well, but we seem to be the biggest. And the ones who are in most urgency to look at groundwater. Now, I don't need to tell you, we have borewells at every scale, so there are, and these are the borewells that are accounted for. In my experience, there are at least 50% borewells which are unregistered. So the number is going to be much more than this, what we have projected. Now, let us come back to Bangalore and say, you all remember the 2024 Bangalore water crisis, summer, 2024 summer. And that is where IISc group was called for to assist BWSSB to look for a solution for this groundwater crisis in Bangalore. And we were involved in trying to find a technical solution to this crisis. And this is just work in progress. And I'll take you through what is it that has been done in this. Just need to say, there was not only groundwater is what happens if you don't have enough examples world over. There is Cape Town, there is San Francisco, there is Jakarta, which is sinking. There are enough examples world over. What happens if the groundwater crisis makes? Now, I must begin by saying groundwater is different in different parts of India. In the hard rock aquifers, groundwater seems almost like petrol. You can't recharge it. You cannot get it back once you exploit in your generation. And in other parts, it may be less crisis prone, where the recharge is much faster. But definitely in the hard rock aquifers, groundwater is a serious issue. And here, what we propose is to monitor groundwater level and also monitor the discharge from the pump. Both we wanted to monitor. We do this by retrofitting a digital starter to the existing motor starter. See, this is the digital starter, what I am moving the arrow on, and this can be retrofitted to any existing starter, any company. And this has a SIM module, and this talks to our server, the cloud-based intelligence, and we have a web app as well as a real-time dashboard. So these are the user interfaces, and from that you can control the borewell as well. So this is the technology that we brought forth, and in addition, these controllers also offer protection from burnouts to the motor as an add-on benefit. But the main issue is to measure both discharge and water level in real time. And so this is the technology that we have used. And so this whole technology is modular. We have many add-on modules, which I'll talk about later. And these add-on modules, we want to make use of them later on if required. Okay. And now this is how on-field installation looks like. Now this is the controller I was speaking about, which is retrofitted into the existing starter. You see the existing starter here. This is BWSSB. This is Ayyappa Temple, West Jalahalli, behind that. And now it is retrofitted into the existing arrangement. Please notice here, this is the existing plumbing system. And our water level and discharge measurement is retrofitted in existing plumbing system. We don't make anything new. This retrofitting takes about 15 minutes if it is GI pipe. If it is PVC pipe, it takes 5 minutes. And we have completed 1,200 installations till now. We are almost doing 300 per week installations everywhere. And there is a centralized dashboard. These are different locations. Now, I just want to stop the PPT and show you a video of what we have achieved through these installations. Permit me to stop the PPT and show a small video.
GPS tracking pinpoints each installation.
I'll share the video right now. You are able to see the.
Yes.
Yeah.
GPS tracking pinpoints each installation, every bore well, precisely mapped and monitored in real time. Track the daily volume of water discharge, knowing exactly how much is pumped, when and where. Monitor water level below surface, observe recharge and drawdown with scientific accuracy. This is a breakthrough innovation that is patent pending. The utilization chart reveals two critical aspects: total discharge and recharge efficiency, empowering planners with real-time intelligence. Access a comprehensive history of every borewell for tracking performance trends across seasons and years. We provide rule-based access, ensuring data security and integrity, empowering every stakeholder responsibly. Track GPS location of all installed systems, your entire groundwater network visible at a glance. The cyclic timer optimizes pumping cycles, balancing energy use and water yield. Device performance insights, helping teams identify inefficiencies, activity gains. From design to field-tested efficacy, Krishi Rudya ensures reliability at every step. Results in action, where GPS tracking,
So this was our work. This was our work. And now I'm back to the PPT. Apologies for this switching over because it does not play if it is embedded.
No problem, sir.
So this is where we were. And these dashboards are live. By March, we will complete 4,000 installations. We are likely to next 6,000, and by 2026 December, we are very likely to have 10,000 such installations data within Bangalore in all the 238 wards. Now, we wanted to say that we got this idea of how to use the data. Many times we get the clues from the farmers themselves, because our 1,200 farmers are already using this data to adjust the pump and rest cycles. They use cyclical timers, and each one have their own customized pump and rest cycles depending on the yield of the borewell. So these are things that, depending on the yield as well as the demand, they have adjusted their own cyclical timers, and they are asking us, can you optimize safe pumping periods, particularly when the borewell yields are low? So there is a lot of interaction with the customers, and they are asking us questions. And we believe we can use this data of water level as well as discharge to get evidence of impact of rainfall and the recharge structures. That means the check dams and whatever you have built, as well as heritage things like irrigation tanks. So what is the impact of that borewells or a region? So we can use to gather evidence of that. It is also important that we will look at interference and cross connections between borewells. So what happens if nearby borewells interfere with each other? And all of this data would be very interesting, and they are already available with us. So coming back to the BWSSB project, these are the impact before and after the project. The first impact is that the BWSSB management is able to get specific details of extraction and operation of each borewell. They were struggling to know what is happening where, and that now they have got a very good handle on what is happening where, what is running, because everything comes to their laptops and mobiles, what is happening where, and we have given a dashboard summary also. Now, they obviously have many more questions on how to use this. One of the happiest person is the waterman. Usually, waterman controls between 5 to 12 borewells, and he had to manually go and visit all of them. It was an issue for them. There is a separate, the waterman explains what benefits he has got. I don't want to show that video because I have to leave the PPT again and switch it on. Later on, if you are interested, the waterman explains the usage of this solution very, very beautifully. And more importantly, all the devices, this fairly advanced electronics, hardware and software, not software, the hardware is installed by the waterman himself. Krishi Hrudaya staff, we do not go to field. These, all the installations, the IoT hardware is installed by the watermen of the BWSSB and the local maintenance contractors. We do not go to field, and we have made it this way only because unless they do it, they take care of it, they are well versed with it. It is not scalable, it is not sustainable. So out of the 1,200 installations, except for the training period, none of them are installed by our company. We make it all ready in the factory, send it, ship it to them, and they do everything themselves. And that is why you can see the expertise of the waterman in handling the hardware as well as operating the web app. He is very proficient, and he other waterman. And this on-ground capability and competence, we were very keen to build, and we are very happy we have achieved that. And one of the things that has become possible is already looking at the water levels, we have some clues as to the summer availability outlook. So we are able to look at water level trends, and we have these things. And the other thing that has become very important for the managers is we have a audit trail, the data log of everything that happens. So thereby, if there is a mistake done, traceability has become possible. They can identify who did the mistake when, in which borewell. So that is very important. The other thing that we have done is we have given soft SCADA. That means there are various hierarchies in managing the borewell, and the master controller rules cannot be overridden by anybody. So the executive engineer is able to set rules and enforce that it is followed, particularly in terms of pumping hours. You know, pumps used to run for 24 hours. Now he is saying not more than 8 hours. There has to be a rest. So he is able to put in rules of use, and not only that, enforce that they are followed by automating the control. Now, even if he switches on the borewell manually, it will not ride. He can't override the command, which has been given through the software. So these things are possible, and the BWSSB management is quite happy that they are able to implement the rules that they have made on ground effectively. And if there is a breach, these are notified. Now, the other thing that has benefited the BWSSB through this solution is that the maintenance cost has come down drastically. Our device, along with the automation, also has an additional feature that we monitor current and voltage every 7 seconds. We measure it, and we set the limits for the minimum and maximum current and voltage. Moment it exceeds, the device trips in less than 4 seconds. Now, so this is able to take care of both factors, the supply side from the electricity board, as well as the load side from the device. If the thrust bearing goes, the current drawn increases. So both the mechanical and the electrical supply faults can be taken care of, and we have avoided burnouts, motor burnouts. A few do happen. It is not that it is 100%. Most of the motor burnouts have happened, and that has drastically reduced the downtime or the disruption in supply, which everybody seems to be happy about, except the guys who repair motors. Okay, everybody else seems to be very happy, and that is something that we have done. Starter repairs are minimized because this is all PCB controlled, and borewell drying out, we hope to give advance warning, and this is something we need to work with experts, geologists and hydrologists. Can we interpret data and give warning about drying out of specific borewells? So that is something that we are working on. We do need a lot of support and help here. Then the other thing that has benefited BWSSB is power bills. Here is a graph. We are able to provide the data on power bills. Each borewell wise, each region wise, we have complete data on the power consumption. And with that, they were able to save a few crores of rupees. Now they have gone and contested the bills that were given by the electricity supply board, saying, this is your data, this is what our data says, and it doesn't tally with your bill. So highlighted. In some cases, they have succeeded. In other cases, they are negotiating. So that is the other benefit that has accrued after this project. There is another issue with the BWSSB that borewells are mostly used by the poor people because they don't pay for it. The Kaveri water is used by the relatively well-off sections because they need to pay for it. Now, particularly in the vulnerable and poor sections of the Bangalore city, they are very keen to know what happens in the summer. Okay, because they cannot afford tanker water. And this is something we want to work on. And they also want to work on what is the combination of Kaveri water supply along with the borewell water supply. So what is the ideal mix for a region? How much should be permitted? What is the ideal mix? Particularly for the coming 26 summer, they are trying to plan. And these are important and very alive questions for the BWSSB. And they would like to integrate these two supplies region-wise, and then they definitely need guidance on this. And so this is the next question, that the dual usage and particularly vulnerable areas we safeguard them. That is something that we are working with BWSSB. We need a lot of help and guidance on this. The fourth part is particularly the strategic planning on water security. Okay, so now it is okay to look at one borewell, but how do you look at a region? How do you look at the whole city? So what are these, wherever there are scarcities, what is the area and source specific planning that you need to do over 1 year, over 5 years, over 10 years? So different time horizons, what would you want to do? So they need guidance on all of this. So multi-source planning for water security for specific regions. Then you need to, in general, shift to anticipatory planning and not do firefighting after the problem has occurred. So not do reactive firefighting. How do we do that? And this is something which already the civil engineering group in IISc is working on, but even they acknowledge that they would need collaboration and help because this is a huge and complex issue, and this is where we are looking for. So what we are proposing as Krishi Hridaya is that we should look at convergence of all the available data. Okay, so this should all converge into resolving this issue, and all the existing well monitoring data from various sources. There is also data on geomorphology that is available. There is daily rainfall data for 130 years in Bangalore. So all of them should be converged. There is experience with many institutions and individuals. All of this has to converge to resolve this issue of strategic planning for the Bangalore city's water security. And this is what we propose. We are very, very keen and happy to be a part of this. and we welcome all the partnerships. I'll skip all this, and we have already talked about it. I also do not want to show dashboard. Unless you are interested, I could show you the live dashboard, how every few seconds the data gets updated from the source. And right now 1200 borewells are supplying us live data. I can show the dashboard. And we also would like to, from whatever we know, we believe such an affordable system done at scale, I stress on affordable, is a global first. It has never been done in anywhere. We have gathered some evidence. We would like the guidance of the audience here to verify if our understanding is true or not. This is not any arrogance, but we want to be clear if this has been done elsewhere. And I would share these details with all of you to please validate and check if what we say is, if our understanding is correct. And we believe this kind of use of IoT in the working borewells is not done in any other program in India. And this is a list of all the programs, the activities happening in India in the different government schemes. And this is all over the world. Okay. So there are two attempts, one in California and another is in Australia. And we believe it is not at this affordable price and not at this scale. Both things are not true. And this is what we want you to verify. And we have given very transparently what is the economic cost of it. Because unless it is affordable, definitely in India, it is not scalable. So affordability and scalability go together. And that is why we wanted to stress on this innovation. And this is what we offer. Here are all the technical specs. What is the accuracy? What is the cost? The technical details of our solution. We would like further guidance and collaboration on these issues. Here are the references where I have drawn my conclusions from. I draw this conclusion from these sources. And what we are working on is much beyond BWSSB. BWSSB is just an example for us. So what we are interested as a company is to provide water intelligence from end to end. End-to-end water intelligence is what it interests us, starting from the borewell and its borewell source, that is the aquifer, and the working of the borewell, all the way to the demand side. We are very interested in looking at demand side. This was just the supply side. On the demand side, we have developed the instrumentation required. So we are able to monitor distribution through automated valves, as well as pressure sensors to detect leaks. So pressure sensors to detect leaks as well as automated valves are already available with us. Then we also have measurement of soil moisture, because that completes the cycle. This goes all the way up to 6 feet because trees use deep soil moisture. So we have soil moisture. We also have system intelligence on simulation modeling, at least for the crop, including percolation rates and everything else. So we also have simulation models. This has been an area of my expertise. I have about 2 decades of experience on simulation modeling, both crop and tree simulation modeling. As I said, this is done for the farming ecosystem. The same tools, I believe, will be useful to the urban ecosystem as well. So simulation modeling experience is with us. So the idea is to provide water intelligence from end to end, from the source aquifer to the supply, as well as the complete demand side. All of that should be available and automated, be available for decision making and strategic planning. It is not just operational decision making. It is also required for strategic planning. So this is what is our intent. And towards this, we believe we need to focus on all the 3 usages of water. For irrigation, which is the biggest use, which is almost 70% of the water used in India, and then drinking water, which is maybe another 13-14%, and then to the industry. So three uses we want to focus on. And in all the three different uses, the common theme is sustainability. How do we make this as a sustainable use? Okay, and what it takes. And we have also developed segment-specific add-on modules. So we have the whole architecture of our solution is modular. Depending on your customer's requirement, we keep adding modules. For example, for the drinking water, they asked us to test quality of the drinking water. Now we have an add-on module which does inline testing of quality. You don't have to take it to the lab. In the pipe, we are able to sample the water at any point in the distribution system or at the source. You can check arsenic, fluoride, any other ions, chlorine, pH, EC, TDS, all of that it is possible to do. Or what is most interesting is you can even check for E. coli, okay, which is an indicator for contamination. So E. coli, all of this is possible to test it either at source or any point in the distribution through your web app. You can trigger the test. You don't have to be there physically present. So you can trigger the test and the result in about 3 minutes time. There is a 3-minute delay because we do the testing by using chemical reagents. We do not use electronic sensors because we found them unreliable in the field. The testing is done by chemical reagents. We replicate the process done in the lab. So it takes about 3 minutes to complete the chemical reaction. So in 3-minute delay, the results will come to your web app or the dashboard. And this, so similarly, for each of these end user requirement, we have developed add-on modules as required. And as I said, our interest is sustainable management in all the three this thing. And there has been a huge lack of information on use of water. So both at supply as well as demand, we aim to bridge the gap at all levels: region, watershed, and river basin. At all these levels, we intend to bridge this gap of lack of information for different users. So what we have done is, we have also developed a capability of scanning fractures. So this was a request that came from our geologist friends. You can leave the camera down and at specific fractures you want to monitor. So it is possible to monitor live fractures in each borewells. Okay. So that capability is another add-on module that we developed. Here is just one pilot that we have done to do that. And I want to skip all this. Here is one long-term monitoring data over 8 months of discharge and water level. And you can see a trend line appearing with some variability on a shorter period. Here is the trend line. This is monitoring data done at the borewell that I own. So on the borewell that I own, I had done long-term monitoring. And now I would like to end with this. So as I said, there are more solutions that we are working on. They are ready, and we would like guidance from interested stakeholders on all of this. First is we are monitoring distribution. There are automated valves. These are not solenoid valves. They are motorized valves. Solenoid valves don't work in the field in our experience. We have done motorized valves which can monitor, and we also sense leakage. There is water quality, which I spoke about. Then the third thing is we have recharge to the borewell, which I spoke about earlier, through smart filters. We have a sand filter which can filter it in the field, and then we detect the clogging of the filter by looking at turbidity sensor. So if the turbidity exceeds a particular threshold, the recharge to the borewell is shut down by an automated valve. So a turbidity sensor, if it exceeds the threshold, immediately it shuts off supplying water to the borewell recharge. So that is how you can safeguard silt moving into the borewell. And then we have made arrangements to backwash the sand filter. the sand filter is backwashed and it becomes reusable. So this is under beta testing already. We are also, a problem has been posed to us that in Bangalore, we are working at the BWSSB owned borewells, but there are far larger private borewells. So even if you do anything with the BWSSB owned borewells, what happens to the private borewells? How do we deal with them? What is the way ahead? We definitely need to brainstorm and come up with solutions. This has been posed to us. We are trying to work on that. But we are looking with interested parties on what is the way ahead for private borewells, which are about 9 lakh in Bangalore itself. Then how do we understand the recharge through water conservation measures which exist? For example, what is the link between the tanks in Bangalore and the recharge to groundwater? Where does it do? Where does it not do? How much does it do? So these links we wanted to document and then utilize, leverage existing structures. So that using the borewell water level measurements will provide some clue, definitely. And that we wanted to look at, as well as I talked of new opportunities in terms of sewage treated water. So what happens to the aquifer when you release this over large areas? How best to use it? So these are kind of things that we are very interested in working on. As I said, the instrumentation that we have is affordable but accurate, and it is easy to use. It doesn't take more than 15 minutes for unskilled people to install. They would need maximum half a day training to install it. So it is scalable. And all this, I have a slide I didn't want to show because of the lack of time. All of these measurements have been validated by engineering group. So they have validated all our water level as well as flow meter measurement by independent methods. Very soon we will be getting a validation certificate from them. Okay, so these are also evaluated by a third party. And with this, I wanted to skip the other slides that I have and end my focus on the groundwater. This completes what I wanted to place before you on two themes that have interested me for a very long time: the rainfall variability and the invisible groundwater, what happens to them. And we have done a small amount of progress. I am very sure that we have made this only a modest beginning. We are very eager and very keen to get partnerships. And this is our whole team. There are also lots of young engineers whom I have not put it here. We also have mentors from the industry. And here are some of our customers. And we have now partnered with a large number of institutions. I have forgotten to mention electronic have been a huge pillar of support. And all of these are our current partners. We have also benefited from earlier research and partnership with number of organizations outside India. And many of them are acknowledged here because we wouldn't have done this work without the prior work we have done with all these organizations. So while we are very grateful to our customers and partners, current partners as well as partners from earlier times, we are looking for more partners. This is too big for any of us to do alone. So we are keen to work together as teams. So thank you very much. I would be very happy to answer questions. And I think I have exceeded my time by 2 minutes. Okay. So I was conscious that I need to take questions. So thank you very much.
Thank you so much, sir. Will you show us the Waterman video?
Yeah, I'll be happy to show.
The live dashboard.
Sure. I'll show you the Waterman video.
ಇದ್ರಾಗ ನಾವು ಆನ್ ಮಾಡಿದಾಗ ಭೂಮಿ ಮೇಲೆ ಎಷ್ಟು ನೀರುಗಳಿದಾವೆ, ಎಷ್ಟು ನಾವು ನೀರ್ ತಗೋತಾ ಇದೀವಿ ಅನ್ನೋದು ಇದ್ರ ಬಗ್ಗೆ ತೋರಿಸುತ್ತೆ. ಇದು ಬಂದು ಪವರ್ KBದು ಪ್ರತಿ ದಿವಸ ಎಷ್ಟು ಸಾರಿ ಇದು ನಾವು ಕರೆಂಟ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅನ್ನೋದು ತೋರಿಸುತ್ತೆ. ಪ್ರತಿ ದಿವಸದ್ದು ಕೌಂಟ್ ಆಗುತ್ತೆ. ಇದು ಟೋಟಲ್ 30 days ಪ್ರತಿಯೊಂದು ಅಪ್ಡೇಟ್ ಆಗುತ್ತೆ. ಇದು ಇವೆಂಟ್ ಅಂತೇಳಿ ಇದು ಪ್ರತಿ ದಿವಸ. ಇವಾಗ ಕೆಲವು ಜನಗಳು ಹೇಳ್ತಾರೆ ಏನಂತ, ನಮ್ಗೆ ನೀರ್ ಬಿಟ್ಟಿಲ್ಲ, ನಮ್ಗೆ ಇವತ್ತು ನೀರ್ ಕೊಟ್ಟಿಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. ಇದು ಪ್ರತಿ ದಿವಸದ್ದು ಕೂಡ ಎಷ್ಟು ಓವರ್ ಆನ್ ಆಗಿದೆ, ಎಷ್ಟು ಸಲ ಟ್ರಿಪ್ ಆಗಿದೆ, ಎಷ್ಟು ಸಲ ವೋಲ್ಟೇಜ್ ಇದೆ, ನಾವು ನೀರ್ಗಳು ಆನ್ ಮಾಡಿದ್ವಾ ಇಲ್ವಾ ಅನ್ನೋದು ಪ್ರತಿಯೊಂದು ಮಾಹಿತಿ ಇದ್ರಾಗ ಗೊತ್ತಾಗುತ್ತೆ. ಇದು ಇದರಿಂದ ಏನ್ ಮಾಹಿತಿ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ, ಇದ್ರಾಗ ಪ್ರತಿ ದಿವಸ ನಾವು ಮೋಟರ್ ಆನ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ನೀರ್ ತಗೋತೀವಿ, ಭೂಮಿಯಿಂದ ಎಷ್ಟು ನೀರ್ ಬರುತ್ತೆ, ಎಷ್ಟು ಲೀಟರ್ ನಮ್ಗೆ ಬರುತ್ತೆ ಅನ್ನೋದು ಮಾಹಿತಿ ನೋಡಿ. ಎಷ್ಟು ಕೌಂಟಿಂಗ್ ತಗೋತಾ ಇದೀವಿ ಅಂತೇಳಿ ಇದ್ರಾಗ ಸೆಕೆಂಡ್ ಸಮೇತ ಓಡ್ತೈತೆ ನೋಡಿ. ಇದರಿಂದ ನಾವು ಎಲ್ಲೇ ಹೊರಗಡೆ ಹೋಗ್ಬೇಕು, ಎಮರ್ಜೆನ್ಸಿ ಇದೆ ಅಥವಾ ಅಪರ್ಜನೆ ಇದೆ, ಊರ್ಗ್ ಹೋಗ್ಬೇಕು ಅಂದ್ರೂ ಕೂಡ ನಾವು ಈ ಮೊಬೈಲ್ ಆಪರೇಟ್ ಮಾಡ್ಬೋದು. ಇದ್ರಾಗ ಸೆಕೆಂಡ್ ಸಮೇತ, ನಿಮಿಷ ಸಮೇತ ನೀರ್ ಏನೇನಿದೆ, ಕರೆಂಟ್ ಸಮೇತ ಪ್ರತಿಯೊಂದು ಅಪ್ಡೇಟ್ ಆಗುತ್ತೆ. ಇದರಿಂದ ಎಲ್ಲಾ ವಾಟರ್ ಮ್ಯಾನ್ ಗಳಿಗೂ ತುಂಬಾ ಅನುಕೂಲ ಆಗುತ್ತೆ. ಇದರಿಂದ ಇನ್ನೊಂದು ಏನು ಬೆನಿಫಿಟ್ ಇದೆ ಅಂತಂದ್ರೆ, ಇವಾಗ ನಮ್ಮ ಏರಿಯಾದಲ್ಲಿ ಅವಾಗ ಸಿಂಗಲ್ ಫೇಸ್ ಆಗೋದು, ಆಮೇಲೆ ಲೈನ್ಗಳು ಚೇಂಜ್ ಮಾಡೋದು, ಈ ರೀತಿ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಸೊ ಈ ರೀತಿ ಮಾಡೋದ್ರಿಂದ ನಮ್ಗೆ ಮೋಟ್ರು ಪ್ರತಿ ಬಾರಿ ಸುಟ್ಟೋಗೋದು. ಇದು ನಾವು ಏನು ಕೃಷಿ ಹೃದಯ ಸಿಸ್ಟಮ್ ನಾವೇನ್ ಅಳವಡಿಸಿದೀವಿ, ಇದರಿಂದಾಗಿ ಇವತ್ತಿನಲ್ಲಿ ಮೋಟ್ರು ಯಾವ್ದೇ ರೀತಿಯಾದ ರಿಪೇರಿಗಳು ಬರೋದಾಗ್ಲಿ ಅಥವಾ ಸುಟ್ಟೋಗೋದಾಗ್ಲಿ ಯಾವ್ದು ಬರುದಿಲ್ಲ. ಸೇಫ್ ಆಗಿ ಮೋಟ್ರ್ ಇರುತ್ತೆ. ಜೊತೆಗೆ ನಮ್ಗೆ ಎಷ್ಟು ಬೇಕು ಅಷ್ಟು, ಅರ್ಧ ಅವರ್ ಬೇಕಾ, 10 ನಿಮಿಷ ಬೇಕಾ, 1 hour ಬೇಕಾ, ಎಷ್ಟಕ್ ಬೇಕು, ರಾತ್ರಿ ಆಗಿರ್ಬೋದು ಅಥವಾ ಮಧ್ಯರಾತ್ರಿ ಅಥವಾ ಬೆಳಿಗ್ಗೆ ಅಥವಾ ನಾವು ಊರಾಗ ಹೋದ್ರು ಕೂಡ ನಮ್ಗೆ ಯಾವಾಗ ಬೇಕು ಅವಾಗ ನಾವು ಮೊಬೈಲಿಗೆ ಆಪರೇಟ್ ಮಾಡ್ಬೋದು. ಇಷ್ಟೊಂದು ಅನುಕೂಲತೆಗಳು ಈ ಕೃಷಿ ಹೃದಯದಲ್ಲಿ ಅವೈಲೇಬಲ್ ತೋರಿಸುತ್ತೆ. ಇದ್ರ
Yeah. So that was the waterman telling us. So he now even installs the software to everybody else's mobile. He has become very proficient. We just send him the APK file. He installs it to everybody. So Rajappa is our unpaid staff.
Thank you so much. You also said you would show us the live dashboard. Can you show?
Sure, I can. I'll show you the live dashboard. How do I do? Screens, documents. Okay. So this is a website. I need to show screens. Yeah. Okay. Uma, I see this is opened in my browser. How do I show something in the browser? Because it is only showing screens.
Yeah, so when you do the share screen option, doesn't it show you options for which screen to share?
No. See, it does not show me anything from the browser.
Yeah,
Now,
we can see your browser now.
from the browser, because this is a website. So how do I do that?
It says the admin dashboard. Is that the one for this?
Yes. Did you see?
Yeah,
Yeah,
please
we
share
could
what
see
you
that.
shared now
Okay,
and just
okay.
select that admin dashboard.
Okay. Okay.
So this is the video.
Okay. You got it?
No, now the video is showing. The video screen.
Okay,
is
one
showing.
second.
Sorry,
First, I'll close the video.
Yeah.
I'll close the video. Okay. I'll again share again.
Yeah.
I'll see admin dashboard. Yeah. Thank you. You are able to see it now?
Yeah. Yeah.
So, yeah, here is the dashboard, and we have you can see total devices, and then divisions of BWSSB, subdivisions, and you can search any of them. You can filter, slice and dice, division-wise, ward-wise, you can select by division, constituency, MLA. You can look at the window that you want to look at data. All these filters will be applied, and this is how you will get individual data. This is the total dashboard, and this is what I show you are live graphs which are combined for all the 1,000 and odd devices. So this is borewell water discharge, all combined data, power consumed, water level, So then this is just a GIS based, you can go. Look, from the map also you can go. Okay. From the map you can go, and what is it? It is somewhere stuck here. But these are the data from the map you can navigate. But let me click on something specific and take you to. So we can click on any of them and go to that individual. Are you able to see this? Hello, Uma?
Yeah.
Yes.
You are able to see this. So
Jagjivan Ramnagar.
Yes. So I'll show you something which was installed when. So now you see live dashboard. We have things like we have complete runtime, on-off cycles, overload trips, underload trips. Whether it is active or not. When was it installed in? So a lot of data comes. For example, you see some of them are installed recently, 9th June. They have been active. So all that comes in the dashboard. So I'll try to look at something that is older.
Okay.
So, all of them are recent. I'll go to something older. So 28 December. See, if there is something inactive, it will show up in the dashboard. So, okay. Let me see this. So this is Adarsha Nagar. Here is the data. Borewell water discharge, water level below surface, water column height. So this is the data of Adarsha Nagar. So now you see total power consumed, voltage, current. This is utilization pattern, event logs. You see, we have everything both from the web app side as well as the device side. Every event is logged. These are very important to get traceability and audit trails. So this is how it goes. And all of them are available. And now you can also, anything can be filtered. All the data can be filtered to the time window that you require. And these kind of updates keep going on. Now you see this is running. Motor is on, power. So this is the voltage and this is the current that is happening here. Okay. So motor HP is 7.5, all that. Installed on 24th December, all the borewell depth is 700. Okay. 700 feet borewell. This is the installed. These are the details. And so you can navigate to any specific borewell from these things. And we are going to add more and more data into this. So this is the live dashboard. And we do have, just to show you, users, we also give you access to users. You see, for example, we have waterman. So we give him a different access. Okay. So we have executive engineer, assistant executive, we have all the people, and each different users. I said we have a software version of the SCADA. So we give different permissions, different access to different users and BWSSB officers. Here are the AEEs in charge of different regions. We have all their contact details, phone numbers, and we also have permissions. So what are they permitted to see? So the whole thing is being managed by through this dashboard. And yeah, BWSSB event logs, yeah, users. Huh. Something just wanted to show you that if you see here, each individual product that we give is, we also have the log of the test it has passed, because we don't want it to fail in the field. We have reports of how they have been tested in the factory. We are original equipment manufacturers. All the hardware is manufactured by us. And here is the test report of each device done in the factory. In Dodbalapur industrial area, we have our own factory. Everything is manufactured by us. And the software is entirely owned by us. Not a single line of code is written by anybody else. To have this ownership. And here is the kind of detail that we have. So if something goes wrong, we know why it happened, how to trace it back. So this is the kind of traceability we maintain for each device. This is the dashboard. If you have anything else, in fact, last time I remember seeing it as 1138, now it is 1139. So one device was installed. So as I said, not only it takes about maximum 15 minutes, within 5 seconds of installation, it will go live. So there is no need for any intervention. And this, we work very hard to achieve this. It should be installed by people like Rajappa, and they should train it, and they should run it, they should maintain it. We should only look at dashboards and enjoy the fun. See, we should not be out in the field, otherwise it does not become scalable. Now you could make out that Rajappa is really proud of what he's doing. Okay, so we wanted to build that as a culture. I mean, all this technology is different, but I think the culture of the people who are working with us, you have to build the culture, you have to build their involvement, you have to build their pride and ownership in it. So they are very happy, particularly at the waterman level. Okay. Yeah. So this was something that was as important as technology to Krishi Hridaya.
Yeah, it's very nice. And what you're saying is absolutely true. Very, very, very comprehensive.
Can I stop the live?
Yeah. Yes, sir, you can
stop. Thank you.
Yeah. Thank you so much, sir. Very detailed and very extensive presentation. So yeah, if anybody has questions, please unmute and ask. Avinash, I thought you had unmuted.
Yeah, let other questions come in, Uma.
I see. So actually, I had a question. This
Please.
is from early in your presentation where you showed that farm in North Karnataka, I think, right? It was.
Yeah.
Where you transform the. You said
this was a Tiptur, not Tiptur.
Tiptur.
Yeah.
Where you said you used the knowledge about the variability of rainfall to, make the farm very productive and green. So can you give us some examples of what exactly you did to, take advantage of the rainfall variability?
Yeah. Okay. First, Uma, because of I did not say it properly. This was done with BIFE, Bird K. Okay. So I was a part of BIFE. So we worked for about 10 years. So there, my contribution was bringing in the rainfall knowledge to that. So the first thing that we did was something very commonsensical. How much rain can you store inside soil so that they will be available to the plants to subplant? So that is what irrigation does, right? during water stress period, can the plants utilize the stored rainwater in the deep layers of the soil? Okay. Now, what are the limits? Now, I was able to work on that and say, how much can you sink in if you do zero runoff in a rainfall area of 60 centimeters, in a region of 60 centimeters rainfall? How much can you go in? How much can you get in? And how do we extract? That is why, and obviously, you must have noticed all of them were trees. There was very little crop there. Okay, because obviously trees only have the ability to go to soil moisture from the deeper layers. So one was, what was the percolation rate? For example, centimeters in rainfall per day, can it all go inside? Because I don't want it to overflow. Now, what are the wet events? And what is the capacity of the storage that you need to design? Because we have limited investment that you can make on soil water storage, isn't it? On water harvest, it costs you quite a lot. What is the optimal storage capacity given the rainfall probability of this region that you should invest in so that it becomes cost effective to do that? Now, all of them are scientific calculations. Now, based on the climatology of that region, 130 years of the region, I was able to work out, okay, and provide. So first is give this. Second is, what are the probability of dry spells, wet spells? Okay, look at that. And can your farming system, because it is crop plus trees, withstand those dry spells and wet dry spells? Two. Third, when do you want to start the crop? For example, when you plant trees, they will not have deep root system for first 3 years, first definitely 2 years. So they are very vulnerable. So start your La Nina year. See, that part I didn't show you. There is El Nino and La Nina. La Nina means our rainfall is always above 50 centimeters. Okay. If it is El Nino, it is always around 30 centimeters. Now, when do you have to start a plantation? You always choose a La Nina year instead of an El Nino year. So and El Nino or La Nina is known in February itself. So you know it ahead of time. You know it 4 months ahead of the planting season. So thereby, you use all this climate knowledge to schedule, to design. So this is actually applying anticipatory planning or design thinking into farming. You must realize farming is very poorly designed. Very poorly designed. You do whatever you want and then grow tomatoes on the road. Who asked you to grow tomatoes? See, there is such poor design that is going on. So all of this science and understanding was used to bring design into farming. Okay. So you use, that is why I talked of convergence. You have to converge all the available knowledge and the expertise from cross-disciplinary domains, isn't it? And that is what we did with Birdcage. And that is how the transformation was possible. Because this is where we looked at convergence, and many of us don't talk to each other, whatever, that silos, if they disappear, something like that is possible by convergence. So what we brought in, I can go in more detail about soil moisture modeling and all that, but they're irrelevant. This is the principle. This is the principle. We do have scientific tools for it. See, the tools are irrelevant. The philosophy, the guiding principle is more important. And this is what we brought in. Okay.
Great. That's really very interesting.
I think we'll need another knowledge sharing session for this concept itself.
Yeah, we would be very happy. And I have now settled in the farm to do this. Just to tell you, I have tried this after working in BIFE in 3,000 acres. I tried it in another 100 acres near Denkani Kote. We got the I was working in a company. I was the VP of a company. I tried it out. It worked so well. We got the CII award for conservation for 2017. We got the CII award. So it was an open competition. We were competing with Tata's and Reliance. Okay. So we got the conservation from CII, which was based on a third-party audit. So these things have worked at scale at 100 acres. And after that, I resigned from the company. Now I am settled on my farm, trying to make it happen in my farm. So then I thought, I'm not young anymore. It is time I do it in my own place. I have done it in other places. So right now I am settled in the farm with, I am attempting to repeat it in my own farm.
Great. Thank you, sir. Any questions from anyone? Any other questions?
Hello.
Yeah.
Am I audible? So my name is Deepa.
Please.
You were talking about 130 years of data that you are working with, but with this climate change that is happening almost every year, every nakshatra probably also would be changing. Also, this is the first time that probably, at least I have seen that data is captured in the nakshatra, so it is nice, good knowledge for us as well. But I wanted to understand, with these climate change in the past couple of years, say if you were to stop your data till say 2022 or 2023, are you able to forecast what is happening across these nakshatra in 24, 25? Compare it to your forecasted data versus your actual data. How much of a variation have you kind of been able to notice to understand the climate change impact? And then, suppose we were to now use, just spoke about planting. The data will probably be something that we should take a call in the next 15-20 days or few weeks for this year. So then it will probably help us get some confidence that this probably is going to be a La Nina or a El Nino year or whatever is going to be the case.
Yeah.
So
first, Deepa, you asked a very nice question. May I know your background so that I'll answer appropriately?
I was working in a corporate for about 20 odd years, so I have some data analysis understanding. Now
Sure.
I'm a farmer from past 2 years.
Wonderful.
And I'm in LKG now to understand and do the farming. It's a dry, semi-arid place that I'm working with. When we bought the land, the rainfall was different. When we are now, the rainfall is very different. So I'm understanding the challenges of water and the soil and everything around.
So thank you, Deepa, because I wanted to be careful when I give you the answer. You asked a very nice question. So now here is my answer. The short answer is, in the semi-arid regions that we are working in, we tested for climate change. This is group of Indian Institute of Science who have been working on monsoons and climate for 4 decades, 5 decades. Some of them are dead now. Okay, they have been working their lifetime on these things. See, this group, we did not find any evidence of climate change in this region. Please be cautious what I'm saying. In this region, we did not find any evidence. That does not mean there is no climate change. We are not denying climate change. You go to Himalayas, you go to Europe, or you go to Western Ghats, there are places where you feel climate change very, very vividly. Okay, it is documented. But in this region that we were interested in, we found zero evidence of climate change. Then we wondered, why is it happening? Why are we not able to do? See, given your data background, you can understand what there is a large amplitude of natural variation that happens in climate variability. Now, climate change is a trend. Now that signal is lost in the amplitude of variation that is natural and inherent to this. Okay, inherent to this region. We tried to detect it. We could not. If you are interested, I will be happy to share the data. Please look for any trends that you can make out. Okay, but we tried. We could not get. So without any evidence, I have to say there is no climate change in this region that we are working in. Now, it may happen in other regions. I have not looked at it there at all. So, number one. Number two, do not include El Nino, La Nina in this climate change because that is a separate phenomenon. Okay, they may be impacted. La Nina, El Nino are large scale phenomenon which are well studied, which are well observed, and they are very predictable. Now you get easily 6 months advance warning, advance projection of La Nina, El Nino. And now what we have done is you look at El Nino, La Nina and correlate our climate events with it. You do calculation. There is a particular word for it in analysis. So you try to, from the historical data, you try to do the back calculation and see whether there is any linkage. Okay, so we take up the phenomenon which are well studied and well documented, and then we link if there is any correlation with our rainfall pattern, and there we find it. So these two are slightly different things. Evidence of climate change and La Nina, El Nino being used for it, we find it as a very strong signal because people need warning and alert before they sow the crop. After they sow the crop, it is useless to them. They have already put their money, right? They have already made the investment. So you need to tell them before May, June, July, okay, much ahead of time, so that they will do something different. If it is a low rainfall year, they will do something different. If it is a high rainfall, it is do something. And that is possible, but you have to do the testing and the data analysis very carefully before you give them a guidance. So I believe I have answered your question. And no in this region. And so any data segmentation and will not help.
Sure. Thank you, sir.
Thank you, Deepa.
Anyone else? Any other questions?
Yeah, I have one question to
Please.
ask. So, sir, with all this data that you're collecting from the devices, and I mean, you showed on the dashboard, right? So I'm guessing there's a lot of data, there's a lot of
Yes.
underground data that also has been collected. So is Krishi Hrudaya planning to use it for any hydrological study, or do you use it for doing any hydrogeological study or predicting trends and patterns that can be useful on the demand side as well?
See, thank you. Again, a very, very nice question. Diksha, we definitely, as a startup, we don't have the competence to do it. Okay. And we are very clear, bleeding heart does not enable me to perform a competence for it, right? You need competent people. So we have already partnered with IISc Civil Engineering Department. We have partnered with the Central Groundwater Board, Groundwater Directorate. We have partnered with the River Rejuvenation Institute, Art of Living. There is a whole group of people there, and these people are working with us. We also have our earlier connections with EPF Lucerne Hydrology Department. So all these people are looking at data. Okay, we are looking at computer science department in Indian Institute of Science who are looking. So all of these people are looking at data, and we now recently are signing an MOU with Well Labs, Dr. Veena Srinivasan. Okay, see, like I already said, we know we need partnership to handle this data, not in one dimensions. This data that we have needs to be looked at in many dimensions. See, one is the hydrology part, other is the demand side part, other is the social part. Okay, there are many, because there are many parts to this particular data usage that we have, and we are now very keen to partner with anybody interested. So we are now striking collaborations with all people, and that on our own, we know we don't have the competency to do it. Okay, I am a biologist, my partner is an engineer, so neither of us have the competency to answer this question, right?
Okay, sure. Thanks.
There's a question in this chat from Venkata Shivareddy. Please unmute and ask. Mr. Venkata Shivareddy.
Yeah, yes, ma'am. So, as sir said, thank you for the presentation, sir. Very knowledgeable one. But in the semi-arid region, as you said, there is no evidence to show that climate change is happened or climate change is happening. So I'm worried. So, what are the indicators to be noticed to know that whether climate change is happening in your semi-arid region?
Yeah, thank you. Which semi-arid region do you refer to?
Yeah,
Can you
it's
just name?
my name is Venkateshwar Reddy. It's in so
Which part of India?
Bangalore rural.
Bangalore
Kolar
rural.
Chikballapur.
Kolar Chikballapur. Okay.
Yeah.
You see, then it is certain that there in these regions also we have checked, there is no evidence of climate change. And now, what is the way ahead? Adapt to the climate variability of your region, and there is huge variability. For example, Pavagada rainfall in the rainy season is 42 centimeters. The standard deviation is 17 centimeters. Plus or minus, it will go. Okay. See, with that kind of standard deviation, you are like, your head is in the refrigerator, your feet is in the oven kind of a situation. See, there is so much of variability. Please adapt to the variability and you will be able to deal with climate change. Okay, so that is the answer. So adapt to variability and address the variability, which is very huge in this region. Okay.
Yes, sir. So that's what variabilities are too high. So that's what we are believing that is because of climate change.
No, it was there even 150 years ago. We have data to show you that.
Okay.
So
okay.
this variability is inherent in this region. It was there in 1920. It was there in Second World War. It was there in emergency.
Okay.
So it did not
was it there before Industrial Revolution, sir? Industrial Revolution? So because
we don't have data.
Okay.
See, I can only answer questions where I have data.
Okay.
Right? Okay. See, if Coorg or some tea estates where they have data for 300 years.
Okay.
You see, wherever Britishers planted, I have seen data for 300 years. There you can answer your question. But in my region, I don't have data.
Thank you so much, sir.
On our region, we don't have data.
Deepa, unmute and ask now.
Sir, you were also talking about the data that you were analyzing for your farm. Wanted to understand, is it possible for us to also download this data from anywhere at a nakshatra level as such, or we have to just take in data at a monthly basis and then, across the years formulate it for each of these nakshatras?
So you don't get data on nakshatras from anywhere. See, you get data in the regular way, according to the Julian calendar. See, what we do is we convert that data into nakshatra data. It is a simple operation for somebody who knows data science. Okay, so we just convert it. And I also told you, because there is a huge body of knowledge lying with the people on nakshatras. See, they have description of rainfall in each nakshatras. Okay, they have conditional probabilities of nakshatras. There is a mountain of knowledge, and we wanted to utilize that knowledge to further our understanding. Just because it is experience based knowledge does not make it less scientific. It is equally scientific. We have actually tested it. Okay, and so we want to use that. That is why moment we speak the same terminology, same terms, then we are able to interchange and learn from each other. Okay, we have done a lot of work on this. I would be very happy to talk on a separate occasion on how much knowledge exists outside the formal science about rain, because rain has been important for centuries to millions of people. They are not dumb, no. They would have formulated their own knowledge systems, isn't it? I mean, so, and we need to learn from that. And this is not just done in India. You have Australia, which is doing it. You have South America, which is doing it. I have seen some aborigine in Australia who is sitting next to a professor in a chamber. So we are not the only ones who are trying it. Everywhere, scientists have recognized the value of this experience-based knowledge. Okay, and they are putting it as a part of the scientific knowledge. Of course, it needs to be verified. You can't have faith in this, but the knowledge is important because it was done based on experience. So that nakshatra-wise, this thing is we can transform, and it will be very interesting.
Thank you, sir.
Thank you.
Any further questions? We're already at 5:40.
I just
Yeah, please.
quickly, Sheshagiri sir, Avinash here.
Yes, Avinash.
As we have discussed earlier, it would be very good if if we find a day where you're able to come and we show you some of the work in Hunsmarnalli, in Devanalli, in Doddajala. So, that's the belt that we've done significant work in, where a lot of what your work can combine with our work to give some very useful insight. And, there, very interestingly, we worked a lot with the watermen there. We have a very good relationship with many of the watermen there. So it would be interesting to explore. So just repeating what I'd earlier said, extending an invitation. So if we can coordinate offline to do that one trip together, sir.
Avinash, yes, certainly. Certainly, yes. And I've already said yes several times. We just need to make it happen, Avinash. Okay. Yeah, let us work on it. I am very happy.
Yeah, I think I have a very small question.
Please.
Given Avinash said you will be visiting us, I think I will ask the other questions to you maybe on the field. But I wanted to check with you, very curious about the devices that you're installing in the borewells. So there is something very similar to a flow meter that is measuring the volume. And so how are you really measuring the change in water level? So do you also then have like a water level sensor that is being put inside the borewell casing, which is then present there throughout, or is it using the electricity voltage? Yeah.
Yeah. So, Ayushi, very good question. Water level sensing is done without a pressure sensor.
Okay.
There is nothing put inside the borewell.
Okay.
Okay. So, as I did not mention it, we had a research project on sensors at my farm, which is also the research station of IISc for 20 years. I run the research station. For 20 years, it was a UN project funded by UN, collaborated with EPF Lausanne and IISc. We ran this project. And so we have a lot of research work done, prior research on sensors. So one of the problems that was central to us was, how do we find the groundwater levels in a working bore well? In an observation well, it is easy.
Yeah.
You can send down the pressure sensor. But
Yes.
in a working bore well, particularly in a 6-inch bore well, there is no gap. You can't send it down. Okay. Even if you send it down, it is very fragile. One shake will smash it away. Okay. So, and again, please, a scalable solution. From the very outset, we were very clear, any solution has to be scalable. And now pressure sensors are costly.
Yeah.
Right? It is minimum 1 lakh depending on the depth.
Yeah.
So our solution costs 20,000. Okay. Now, if you put 1 lakh, then nobody affords it. Forget farmers, even government won't afford it at scale.
Yeah.
See, we couldn't have done the BWSSB project with pressure sensors. One is the price. Second is you need to pull out the pump to install the pressure sensor, which is impossible. Okay.
Yeah.
Which is a big hassle. So during our research project itself, we were focusing on a innovation which will give you water level by installing sensors above the ground, not below the ground. Now,
Okay.
how do we do that? Okay. So we have succeeded in that. And that I can give you, I can confirm to you there is nothing below ground. So you don't need to pull up the pump. It is all above ground.
Right.
And I can confirm to you it is working because it is validated. If you need more details, our patent is pending. We will get it in next 2 months. We can tell you everything you want to know.
Sure.
So let the patent is already published. It is under examination. Next 2 months, we will get the patent. We will be happy to share it with you. That is why we were confident it is a breakthrough innovation.
True. Yeah.
Nobody else has done this. And we are very keen to, and the purpose of was to scale it up.
Yeah.
Okay. And as a company, we were under pressure to price it high. So we did not succumb to that pressure. Okay. Because the alternative is definitely 1 lakh and above. So why do you price it at 20,000, which does the same job? So we made it low simply because we want to scale up.
Got it. Okay. So when we say above the ground, it is with the retrofit unit that you showed. It is there.
It is with
so
that. It is
irrespective of if it's a bore well, if it's an open well, it can always be, as long as there is a motor, one can measure the water level changes.
Absolutely right. You are spot on. Okay, that's right.
So I think, I mean, based on all the various like applications of this, we really see that a lot of this can fit in our work and complement the work that we are doing, make it much easier for us. So yeah, really looking forward to you coming here, and we'll see you on the field. Yeah.
Yeah, as I said, I have said yes multiple times. We will only grow by collaboration.
Sure.
We will only grow. See, this is too big for any of us individually.
True.
There is a question from Shivashankar. Please unmute and ask, Mr. Shivashankar. You're not audible if you're saying something, though you're unmuted. Now you're muted. No, not audible. Okay, I'll read out your question. He's asking, can we have an exposure to your research station?
First, yes. Yes. Your founder member visited us, I think, 20 years ago. Vishwanath came and saw our research station, which is my home, 20 years ago. So when he has come, you are also very welcome. Okay. But
yeah, Shivashankar, he says he's from Mairada.
Yeah, sure. We are most welcome to visit us. And we should actually visit our installations. See, in every ward, we have already begun installing. If you tell us, you can actually go visit the installations in Bangalore. Okay. And you should see them working. And if you want, I will tie you up with our installation team. You can actually go with them on an installation trip, see how it is done in the field, because it is important to experience actual installation. No, all the dashboards are fine. You should see it work on the field. The
Sir,
way
can
it
I
Yes,
is.
share
I
your
think that's a
email
very good
ID?
idea. Yeah, yeah. So, Uma, that's a good idea. So, I think we should choose, maybe near the DJ Halli or
Yeah,
near, some place where we work intensively.
yeah,
If if a small team of us go and see the installation, see the
yes,
thing, and let's do that also as one of the action points, apart from her coming and seeing
yeah.
uh,
Yeah.
Hunsmarnalli and all of that.
Please see installations, because see, finally, to scale up, it should be done by people who are available. You can't send teams everywhere, right? The local guys should be able to do it.
True. Sir,
So
can I
I will
share your email ID on the chat
let me
here?
know when you want to do it. I will tie you up with the installation team. Please go ahead and work with them.
Sir, can I share your email IDs on the chat
Please,
here?
please. You should share my official email ID, Krishi Hridaya.
Okay.
Krishi Hridaya email ID. Please share my phone number, official email ID. Please share. Yeah.
Sure. Any other questions? Does anybody have? Here is Sir's email ID and phone number, those who want to get in touch with him.
Sure.
So thank you so much, sir. It was very, very nice, very detailed, and so much of information and knowledge. So thank you very much. And we hope to see you soon.
Thank you,
Here
Uma.
at your
We
installation.
will follow up. We will follow up, sir.
We will follow up with you
Uma,
for sure.
how many of you are there who do not belong to Biome?
On this chat right now, one, two people, three people. Rest of us are from Biome.
Okay.
Four people. Sorry, four people. The rest of us are from Biome.
Yeah, very nice. Thank you.
But at one point there were 24 people on the call, sir.
Yeah. No problem.
Most of them were from other, quite a few. Those who are doing farming and all were also there.
Sure. Fine. Thank you.
So thank you so much. Thanks everyone for attending the session as well, and thank you so much, Ms. Sheshagiri Rao. And I will end the meeting now for everybody.
Bye.
Thank you so much.
Thank you, sir. Bye.
Bye.